Welcome to Programming in Modern C++. We are in week 5 and I am going to discuss module 23. This is on inheritance. In the last 2 modules, we have introduced the concept of is-a relationship in object-oriented analysis and design, and we have introduced the basic semantics of inheritance, particularly in terms of the data members of derived class and base class. So, the key take back has been that the derived class has all the data members of the base class, a complete instance of the base class in its object layout. And we have also discussed about the inheritance of member functions. Derived class inherits all member functions, non-static member functions of the base class. It can override a member function, it can provide multiple overloads to a member function, or it can add new member functions. So, in this module, we will first introduce the concept of protected access specifier to kind of provide a solution that under the semantics of inheritance, the original objective of the first objective of object oriented analysis and design, that is encapsulation, is seeming like breaking down. So, we will have to restore by providing a new access specifier, and then we will understand the construction and destruction process on a hierarchy and revisit the object lifetime concepts we had discussed earlier. So, this is the outline, it is available on left. So, inheritance on C++. So, up to this point we have discussed, now we are going to discuss this part, starting with the access specification and then continuing in the object construction. So, what is protected access? Derived is a base. In this, under this situation, the derived class cannot access the private members of the base class. So, let us understand the requirement once more. So, I have the base class, I have the derived class, I have an is-a relationship between them. So, if I have a member here, I will have it in derived, that is fine. But the question is, if I have a member which is private, then the derived class, object of the derived class or the derived class per se, will not be able to access it because it is private. It is encapsulated completely. It was required to encapsulate the original class base. So, we have to stick to that. If it is in public, if that member is in public, then the object of the derived class or the derived class member functions would be able to access it, because everyone can access it, right. So, this will lead to a new challenge in terms of the encapsulation. If I keep the data member only in private, then it is of use by base. The derived has to carry the instance, but derived cannot do anything, cannot exchange information with that, cannot do any computation with that. If it is kept as public, then the encapsulation is gone. So, you can feel that the what has been provided in terms of private and public is good for a single class only, and using that and the get set idioms and all that, you can have a very nice flexible model of information hiding. But that seems to break down when we have this kind of a generalized specialized class structure. So, the protected access specifier is provided to solve this problem. So, it is to be introduced in the base class. Now, it has a very interesting semantics. The semantics is a derived class can access protected members of the base class. No other class or global function can access protected members. So, if I think about protected members, then it is like public in the derived class, and it is like private elsewhere, anywhere else. So, that is very. So, this fine grain or finer grain access control, access specification restores the information hiding property over a object hierarchy, because now we can just use public and private within a single class for information hiding within that class. On a ensemble of classes which are related by easier relationship, by generalization specialization, we can have three types of control to decide what is exclusively for use within the class, which will go to private, what is the final interface for others, which all will go into public, and what is specific at different stages of this hierarchy of easier relationship, which will go into the protected. Right? So, this is the basic understanding with which the protected access specifier will have to looked at. So, let me start with an example. Let us think about private access. So, I have private access, I have a data in that, I have a public access, I have a print in that. Then class D is derived from class B, and it has a private data info, and it has what it has done, it has put print again. So, it has overridden the print function of B, put it to public, right? Easy to see. Now, this print will not have any difficulty, because it is a single class scenario. So, if I construct an instance of this, I call b dot print, things are all fine. What happens if I construct an instance of D, the derived class object, and try to call the derived class function, this function from here? Now, I can see, to be able to print a derived class object, it has to print both the base part as well as the derived data members, that is derived class data member rather, derived class data members which it has added. So, when it tries to print the base part, it tries to access data which is in the private of the base class B. So, it is inaccessible. It is inaccessible to child, it is inaccessible to D. So, this code simply will not compile. Either B will have to break the encapsulation by providing get set function. If it does, then it is available to others as well, not only to class D, it will be available to anyone else. So, this is the problem that happens when I do D dot print, and this, because of this lack of access, this code will not compile. And obviously, if I directly want to use b dot data for everybody, this is inaccessible and this will not compile. Conclusion, D colon print, this one, D colon print cannot access B colon colon data as it is private. Let us now try to solve this problem. We put this in protected access specification. This means that it is accessible to child, it is accessible to D, but it is not accessible to others, like when it was in the public, it was in the private. So, this print function has no issue, object B, B dot print, these are good as it were. What happens in the overridden function print in class D is the data of B, which was earlier inaccessible, is now accessible because it is in protected. So, this code will compile perfectly fine, and info of course is its own data, so it can access. So, now this also will work fine. So, D colon colon print can access this data, B colon colon data, this can access this is access is possible because it is in the protected access specification. Okay. If you come to B dot data, earlier it was private, so nobody could use it. If you look at B dot data, again it is inaccessible to everyone. So, you have what you have achieved is you have not changed your encapsulation to the external world, you have not changed your access within the class, but you have kind of created a privilege pipe of rights between the base class and the derived class. This is certainly true. I mean, obviously, if I talk about human inheritance, certainly I will have rights which are specific to my parents, which others will not have. Right? This is beyond the rights that my parents will have on their own, on which even I cannot intrude upon. So, it is just that concept being put in the semantics of C++. Right? So, this is my protected access mechanism. We can see some more of the consequences that we have created, particularly this is with the protected data in B. What if I write a friend function? Earlier what we did was a member function. The friend function will be able to print. So, I have B instance, I do cout P, it will print B object colon 0. Right. Same thing would happen here, no difference. Now, suppose if I look at the class derived class D. Now, do I need to provide this operator overload again? The answer is yes, because since this is a friend function, this will not be inherited by the derived class D. So, if I try to construct a D object and try to do this, then what I get is I get a operator with what do I have? Cout, which is fine in no stream, and then I have D, which is of type D. But what I expect is a B. Now, here the compiler does something interesting. The compiler figures out that, well, I need a B object. What you have given me is a D object, which is actually bigger. So, I have this D object, and within that I have a base part of the D object. So, and then I have info here. The compiler knows that it has a B object part embedded here. So, what it does? It simply takes this part and uses it as the B object instead of taking the whole of D. Of course, it does not even know the whole of D. Right? So, what happens as a consequence of that, when you try to do this, you have two data members, one in the base class as data, another in the derived class as info. Only the base class part 1 is printed. But if you provide a separate friend function to overload operator output streaming with a D class parameter and naturally printing the D info, then this will print. So, this is just to show you before we get into the constructor destructor, which are these, just to show you that one is how you carry on the information hiding encapsulation through protected, and when you break that, how does it work with the protected? It works in the same way as it were with the private. There is no special consequences, but you will have to remember the fact that breaking encapsulation by friend is not inherited. So, it has to be, it is just not going to solve that you have allowed access by giving protected, but you will have to follow your other semantic rules of providing a separate friend overload for the operator that you want. So, let me move on to the core of the object side, the constructor and destructor. Now, what are the things that I have? I will say that the derived class does not inherit the constructor or destructor of the base class. Please do not get me wrong, and maybe some literature would say that it does inherit, but inheritance, having mere access is not inheritance. You may inherit, but may not have access. You may not inherit, but may have access. Right? So, you have to distinguish between them. In case of constructor destructor, you do not inherit them, because they do not become your member functions. First of all, constructor is static, so it cannot be. But more importantly, both constructor and destructor are named by the class. So, base class's constructor destructor has no semantic meaning in the derived class. So, you do not inherit them, but you must have access to them. Why do you have access to them? Because in object layout, in the derived class, a base class part, a base class instance is getting created. Now, naturally, the base class does not, the derived class does not know how to create the base class object. So, it has to use the constructor for that, same for the destructor. So, this is a very one thing. In addition, naturally, the base derived class must provide its own constructor and destructor, right. There is no moving away from that. And as we have noted, derived class cannot overwrite or overload the constructor or the destructor, right. It cannot overwrite, neither can it overload constructor or destructor of the base class. Right. And then we will have to work on the actual sequence of doing things. Certainly, base class object instance is a part of the derived class object layout. So, when you go to construct a derived class object, you must first have to construct the base class part of it, and then only the derived class part can be constructed, because the derived class part may use some of the values that the base class part has, right, some of the data members that base class part has. Similarly, the destruction has to go in the reverse order. So, let me illustrate this through a simple example. There is a base class, one data which I have kept in protected, just for, because it is only for this, and the constructor destructor is put in public. I could have put them also in protected. If I put them in protected, then I will not be able to construct a B object as I am doing here outside. So, I have kept it in the public. Now, what is the constructor? The constructor is B is a constructor with a default parameter. So, basically I have two constructors, one is B int and another is just B. One is default, another is B int, and I have the destructor. Simple scenario. In the class D, derived class of B, I have kept the info in private because it's just single inheritance I am showing. Constructor destructors are public, so that I can use them. Now, let us look at the constructor. So, again I will write here B int, two constructors I have, and B nothing. I have a constructor which takes two parameters. So, I have D int int. The meaning I am taking is this int is meant to be the data of the base class, and this I should be the info, the info of the derived class. That is what I am. So, what I will have to do? If I am doing it for say D1, which is 1, 2 I have called. So, D is 1. So, I have to first construct this part of the object, the instance which is embedded. So, I call BD. So, from here I am calling B int. To construct this, so in terms of initialization now, it is not enough just to initialize the data members of the class. I have to initialize the base class part of that. So, that is the first thing I have to do. Again, it does not matter in which order I write. Wherever I write this is always going to be the first on the initializer list to be done, right, because without that I cannot proceed. And then I do the rest, which does this part. I have a second constructor given which takes only one parameter. So, that is D int. What it does, just look at, it is not, it also needs to construct the base class instance, but it is not calling the base class constructor. So, it is like D D2. If it is doing like this, what it means that the default constructor of the base class must be there and will be invoked. So, first this is invoked, though it is not written, but it has to construct. So, if base class, it finds that base class has a default constructor. So, it constructs with the default constructor, which it sets it to 0. So, you get this part of the object D2 specified set, and which means that this second constructor of the derived class is using the default constructor of the base class. Right. So, this gets constructed, and then on the initializer info is set to I, which is 3. So, this part is created. So, this is the basic mechanism that has to happen. So, in construction it will always be the constructor of the base class which will be invoked, and then the rest of the initialization of the data members of the derived class in the order they are listed. We have understood these rules well, then those will be covered one after the other. It is important to see that suppose here I had given a default constructor in the process. What if I did not write this, did not default this parameter? So, what will mean? That I have only one constructor which is B int. In that case, this constructor which requires B default, because I have not invoked it, does not get an appropriate constructor in the base class, not there. So, this constructor with the default constructor of base expected will simply not compile, because compiler does not know which constructor to call. It needs a parameter, so you have not given that, which you have given here. So, this is okay, but this will not be okay. Similarly, of course, the other possible case is much easier to see, that instead of writing this, if I had just written the default, then obviously this will compile, this will not compile because of the parameter mismatch. Right. So, this is the basic construction story in terms of a specialization of a derived class from a base class. The destruction does not need any specification, because you know what you have and you just destroy things in the reverse order of how you have created. So, this naturally impacts your lifetime. So, I will end with a lifetime example of the same design. So, you have base class with this pair of default and non-default constructor, and two constructors for the derived class and these instances. So, what will happen when so in what you see in terms of magenta is the trace of the output that you are getting. So, first this has to be constructed. So, the base class constructor with int value 0 will get called object B. Then this will have to get constructed, which means that the base class constructor with the value d, which is 1, has to first happen. So, the base class constructor is called with value 1, then only the remaining part of the derived class construction can happen. The derived class construction can happen. So, now you have the derived class construction with 1, 2. So, this was here the object d 1 is ready, here it was being worked on, it was partially ready. Then you have d 2. So, this will use this constructor, which means it will use the default constructor of the base class. So, again you have the base class constructor, this is a typo, this should be removed. This is a base class default constructor, which naturally takes the value 0, partially d 2 is constructed, then this constructor of derived class d goes on and you have the object d 2 constructed. So, this is all on in, this is how the lifetime of these objects one after the other are studying. So, it is objects as well as the base part of the embedded of the derived class object. So, you can easily see that the way it will happen is the destruction will happen in the reverse order. So, first you will have the destructor called for the last object d 2 created. Now, what you will have to do? It has to destroy the base class. So, it will call the destructor of the base class for the value 0, and then the task gets completed. Next is destruction for d 1, which calls the destructor for class B with the having the value 1. So, the destruction of d 1 gets completed, and finally, the destruction for the base class object B, which is with value 0, and object B gets destructed, and that completes the lifetime scenario of all of these objects. And I have purposefully taken a very simple, whenever there is a key idea to retain or to use in several times in your programming, in your assignments, examination, I try to put a key small example which captures the entire thing in one slide. So, that you can just refer to this slide and you have the entire answer to the object lifetime under construction destruction of base class derived class object. Everything else is an extension of that. You can have further derivations, you can have hybrid inheritance, you can have multi-level inheritance, you can have various contexts in which these objects are placed. They could be automatic, they could be static, they could be constant, non-constant, everything else you can work out based on your earlier knowledge, but this is the core of how objects get constructed and destructed if they are on a hierarchy. So, this brings us to the end of this module, where we have understood the use of protected access specifier, and in particular how does it help in providing the preservation of information hiding in a proper manner on the hierarchy, and then we have discussed the very critical construction destruction process of class hierarchy and the related object lifetime. I hope you have enjoyed this, and this we are going to a very key area of C++ and object oriented design. So, please make sure that you understand these very well. You can start practicing them, and going on to the next module, I will take up a little bigger example of the phone to give you illustration on how the complete story can be stitched together. Thank you very much.